Welcome back to Educator.com. Today we're going to make a little special emphasis on handling character strings in C++. Okay, we've done a lot of numbers and floating points and variables and all sorts of wonderful things, and just sort of glossed over character strings as here, print this and don't worry about it. We're going to take a little bit closer look at it today. There are two kinds of character strings that you need to deal with in C++. There's the string object, an object such as object-oriented, which has its own attributes and its own methods, its own access functions. Then there's the classic C string, which has been around ever since C was invented, which is a null-terminated array of characters. And it's just like any other kind of array. It's just a special array that it gets treated like a character string. So the string object overloads operators, like you have the plus sign and the plus equal assignment operator, and your comparison operators that let you take a string object and make expressions with it, which you can't do with a classic C string. So it includes member functions, which can be used in other processes, which allows you to do various things like find the next space or get a substring and various other things like that. The classic C string requires caution because you do have to allocate memory for it. The object will automatically reallocate as much memory as you need for a given operation, whereas the classic C string, it's on you as the programmer to make sure you have enough space for whatever you're going to do. So we're going to show some functions from the standard library and some methods that are in the library for the string object. And the classic C string, even though you might say, well, that's obsolete now, there are still some functions and methods that are in the C++ standard library that require a classic C string versus the new C++ object string. So like I say, we have two kinds of strings. The object string in C++. The data is stored in private fields. You don't know how the data for a character string is stored, and you're not supposed to know. Maybe you put some data here, a little bit more data there, and a whole bunch of space allocated so that if it grows, it'll grow into that space and whatever. You don't know, you don't care. You just know it's in there, and you don't have access to it. But there are methods to get that data out as if it was just a continuous string of n number of bytes. And there are operators, as I mentioned before, there's operators that are overloaded. So you can have a string A is equal to Chicago and use the plus operator and have White Sox. So that'll give you a string concatenation that says Chicago White Sox because of the plus operator. The classic strings in C is an array of type char. You don't have operator overloading. You do have a pointer to an array of type char, or you can have just either the pointer to an array, or you can either have an array of characters allocated in memory, or you can have a pointer somewhere that points into that array. And it has to be null terminated. Unlike the object, the classic C, you know exactly how it works, and you can write code that takes advantage of that, which can be good or it can be bad, but you know precisely how the string works. We have standard library functions for accessing and manipulating, concatenating, copying, etc. And like I said, because of the fact that the programmer is doing the allocation work, you have to be more cautious with a classic C string. Okay, the C++ string object, their interface is defined in the string include file. Here we have some useful member functions. At returns the character at the nth position, which is pretty much the same way for a classic string if you were to use the square bracket as an operator, which also returns the character at the nth position. But there are no runtime checks with this. The at has a thing, well, if you go off the edge or if you go off the edge the other way, it will actually crash. Whereas this one will work almost exactly the same as a classic C, which means it's unpredictable what will happen if you go off the end of your array. Your plus sign is overloaded so that you can concatenate two strings together. Plus equal is overloaded so that you can have a string and use plus equal and append something to the end of it. And there's other overloaded operators. Double equal, see, are these two strings equal? Less than, greater than, there's also greater than, equal, etc., etc., etc. And as well as the double equal, there's compare. So you have a string and you call the member function compare to another string. It will compare those two strings together. And this is useful for different functions that you may have to invoke that require a compare function. So like if you're sorting some random data, or if you call a sort for an array or a sort for an array of structures, you have to provide the sort routine with a compare routine so it knows how to tell if these two objects are less than or greater than each other. So this is that method, that function for that. You have find, so you have a string and you're looking for a string. You want to start looking at the nth position, and if it finds it, it will return to you the position of that string that it found. Otherwise, it will return -1. You can insert a string at the nth position. You can replace a string, whatever's in the string before, at that position, that many bytes. You replace it with this string. Length is very straightforward. How long is my string? And then C string, because of the fact that there's so many functions out there that require a classic C string, you can take the string object and get something that's exactly the same thing as a classic C string. It's null terminated and everything else. There's also something I should have put on this list called substring, which you can give it the position and the length. So if you have a string that says hello, you should give me the substring starting at 3, that's a length of 2, it'll bring back your low.